We will solve the next problem. Here, all the problems are similar. So I would request you to be thorough with the first type of problem. In the last video where we solved two problems, be thorough with it. Once you understand the main concept, the similar concept is applied in all the problems. See over here, you have been given two equations, but cos, that is a trigonometry function, is given, and y is equal to x squared. Even before anything, you must remember the basics of the graph. Now, if I have this axis, you might remember cos always starts from 1, isn't it? It starts like this and it goes on like a wave. And even it continues the same thing behind like this. It keeps on going. What about this y equals x squared? It is a parabola opening upward. So it's something like this. Sorry, it should touch over here. Now there is no coefficient, no constants, nothing. So it's this. Okay. So now this is the graph. How would you solve? You should know the upper function, lower function, and just what we had learned in the previous problem, the same thing will be applied. It's very simple. So now over here, with the basic knowledge I've just drawn over here, see, only this part is into consideration. Why? Because you will find the points of intersection and that is it. You don't want any other points. See this point of intersection and this point of intersection. That's it. This is the area which you want, right? So all you're doing is step 1, sketch the graph and understand them, and step 2 is find the points of intersection. How do you find the points of intersection? That is by equating these both graphs. Equate these both graphs, that is cos x equal to x squared. Now there are different ways you can do other approximation methods as well to solve this, but we will stick to the calculator method, which is very easy. Now over here, all you need to do is directly cos alpha x, close the bracket, minus alpha x squared. Remember one important thing. If I press equal to a shift and equal, you shift and calc, I'm not getting the correct answer. This is wrong. Well, because I'm using cos, so this needs to be changed to radian mode, shift, mode, and 4. Now press shift and solve. Sorry, I have not written it properly. I need to make it equal to 0. Now press shift and solve. I'm getting 0.8241. Now over here, you sometimes you can even solve the other way around. That is, this equal to can be over here and shift and solve. You'll get the same answer. I'll show you. What I mean is just this equation as it is equal to. Okay, shift and solve. That's the same answer. Okay. Now over here, you must remember one thing. You're having two points of intersection, but you know parabola and cos over here, it's symmetrical, right? If this is 0.1, then this is -1. If this is 2, then over here you'll have -2. So now we have one point of intersection as 0.8, then one more will be minus 0.8. So this will be negative as well. So you will have 2 points, that is 0.824 over here and minus 0.824, because the square is there, and also you can see it from the graph. Now once you know, very simple, what we have done already, that is integrated from these limits. The lower limit is negative number, the higher limit is the upper number. So integrate from minus 0.824 to a positive 0.824. What is the upper function? This is the cos graph minus the parabola x squared. See, x squared is down, cos graph is up. So the answer is A is equal to 1.09475 units. You can approximate it and write 1.09, or depends on the options. Similarly, over here we have one more problem. Same like what we just now did, but the only thing over here is we have three functions. Now you can see, find the area bounded by graphs of y equals x squared, y equals 2 minus x, and y equals 0. So what happens? If you graph them, now let's think a basic graph. Y is equal to 0 is a straight line. That's very easy. Y equals x squared. That means, imagine this is the x-axis. It's something like this, and it goes up like this. And 2 minus x, that means 1, 2. If this is the second line, then we will have a line something like this. So now what are the points of intersection? This is 1, 2, 3. So you will have one point of intersection over here, and this over here. There are 3 points of intersections. So let us see now. Let's solve this, sketch the graphs. See, whatever I just now drew, this part is only considered, okay? I drew the entire graphs. This is rough sketches. It's not accurate. Now over here, we get these 3 parts. This, and this. These are the 3 equations. Y equals 0 means just a straight line over here. Now we should see which is the upper function and lower function. But look carefully. Is the upper function upper itself all the time? No, only until over here. So this is similar to the last video which we saw, a problem where the function changed. Over here the functions are not changing. The below function is same, but I mean you're not swapping the functions, but you have 3 different functions. So what happens is, initially, see, you need to solve this as a1, see, this area, and then add the second area. This is what we did before as well. So solve this 2 functions, upper function minus lower function, separately, and then upper function and lower function. Sorry. So this is how we can easily solve it. Now over here, find the points of intersection. Now obviously you know we have to equate these equations together. X square equal to 2 minus x. So y are all equal, right? So this equals this. Solve it. You can solve it in calculator. You will get the answer. Now I'll come to this in a minute, but solve the other one as well. Over here, x square equals to 0. Now you'll get this answer, and 2 minus x is equal to 0. You'll get this answer. Now, from here, you can understand one thing. This point, okay, this point, and this point is the limit. Okay, in this graph, you must understand, because only these 3 points are there. Okay, whatever, wherever it makes at the, x-axis, see, this is the limit. You can't extend it beyond 0. Can you? No, because we are dealing with this graph. Okay, so can you consider this minus 2? See, what happens is this goes on and this line even intersects somewhere over here. But you're not interested in that point. You're just interested within the 0 to 2 point. That is only positive 1. So that's why we are discarding this. Okay, that point of intersection is not considered. Only x equals 1 is considered. Then 0 and 2. Now what? Just substitute the values in the formula and solve. We have done this already. From 0 to 1, see, from 0 to 1, the upper function is x square minus 0. And from 1 to 2, the upper function is 2 minus x minus 0. You can use the formula or directly put this in calculator and solve it, and this will be your answer.